Okay, geometry kids. Kind of a dark setting here. Sorry about that. I need to work on my lighting. But this is a problem I want to go through today. So the problem is this. It's in the book. I talked about it right at the end of the first video. We have a circle, a large circle, like so. Okay. Inside of the circle is a square. And the square is kind of, it's going to hit all four corners. So the four corners is going to be drawn this way. Looks like that, and that. Please pretend that is a square. They are straight lines. Remember, don't trust what the lines look like in geometry. All right. And what we know is that from the center of the circle to the corner of a square, the distance is 3. Now, I forgot whether or not they told you the distance was, that's what they told you. I think the distance was 3. Our goal, figure out what is the area of the shaded spot, this stuff here. How much of this, these four little arcs, what is the area of that based on our information? All right. So that means obviously we need to figure out the area of the circle. Then we need to subtract the area of the square, and we'll get it. Sounds so simple. I made a couple of key errors on this, however. So let's first of all do the easy stuff. The area of the circle. Area of the circle, the radius is 3. We know that the radius of a circle is pi r squared. The radius squared is 9. The area of this circle is 9 pi. 9 pi. We're going to put this right over here and leave it there. And now we got to tackle the square. Boy, did I make some big mistakes on this last week or yesterday. Here's a square. I'm going to make it upright so I can look at it. That was my problem. And I have a point, and I have this point going over here. Now, for some reason, I was thinking, and this was the biggest, it sent me down a rabbit hole that I couldn't quite get out of. Remember last week we did apothms? The area of a polygon is 1/2 of the apothem times the perimeter. And I was thinking, since this is a regular polygon, that this would work also. And for some reason, I don't know what I was thinking. I was thinking that was the apothem. It's not the apothem. The apothem would be the area down this way here. Anyway, and I got down, I got some weird numbers, and I was way off, and I finally got it figured out. So if area is 3 here, we do need to figure out, the length is 3. We've got to figure out the area of this square. So how do I do that? Well, if this is 3, this is 3. All right, being a square, perpendicular, the bisectors, the diagonals bisect each other at 90-degree angles. This is a 90-degree angle. All right, now it's looking pretty good. I use a Pythagorean theorem. I can find the length right here. 3 squared is 9, plus 3 squared is 9 equals 18. So this area here is the square root of 18. Here's my first mistake I made. This is so easy. Can you read that? It just looked very good there. It should be the square root of 18 right down there. Now, right now, I'm cooking with gas. I'm almost done. But what I did, I was so used to putting these radicals into simplest radical form. I go, well, I better do that because square root of 18 is 9 times 2. And I simplified it as 2 root 3. And that's not true. That's not true. It's 3 root 2. Big mistake, sent me down to some wrong stuff. But more importantly, I was trying to apply this apothem theorem. Don't make it too hard. I didn't need to do that. I've got the length that side. It's so simple. Square root of 18. I can get rid of this whole thing. The square root of 18 times the square root of 18 will be the area of that square. And you know, the square root of 18 times the square root of 18 is 18. So the area of the square is 18. Right in there, 18. The circle is 9 pi. So the answer would be then the area of the circle minus the area of the square. 9 pi, put it up, can you read it? 9 pi minus 18. And if you got your, so sometimes the book will allow that, or we'll use that as an answer, but since this is kind of an application problem, we do want to break out the calculator and literally go 9 times pi minus 18, 9 pi minus 18, And you will get, when you do that, 10 point, that is approximately equal to, not the equal sign, approximately, because pi is an irrational number, 10.3. So that is the answer for, or that an example of composite figures with some irrational numbers thrown in there. Okay, 5 minutes to go, so get to work on those today. One more thing, I'll probably say this also in the preview. I'll probably say this earlier in the first video also. In your answer sheets, when you submit your answer, you can. I've activated attaching a file to that. And kids have now started showing their work. If you have a problem, you can just take a picture of your paper and just download that and put that on the answers when you submit them to me. Oh, video clue. Last one was Jack in the Box. We'll stick with the classic toy genre, and we go to crayons. Okay, crayons. That is your video clue to show you've watched this. Crayons today, the old classic eight pack of crayons. So that's that example. Get to work, kids. Just get to work.